Okay, good afternoon once again. Exploring the solar system, part 3. What can we do from earthbound, or at least relatively close to Earth, telescopes, rather than sending spacecraft out there? So, as you, I'm sure, are aware, we've had telescopes here on Earth for 400 or so years. I'll be saying briefly something about our first views of the solar system through those telescopes and some of the latest views, and where are we going next with the telescopes that we would like to build. So 400 years of telescopes didn't necessarily start with Galileo. He was one of the first to use a telescope to point it at the night sky and document and record what it was he was seeing. And since then, telescopes have developed, preferably avoiding using lenses in favor of mirrors, because they can allow us to have larger objectives, larger collecting areas, and not worry too much about the way glass splits light into its component colors. So it wasn't long before the development of telescopes went from lenses to mirrors, and by the turn of the century we were building large telescopes like this with mirrors meters in size rather than centimeters in size. And when I was born, the largest telescope in the world was this one, the Hale telescope, the so-called 200-inch or 5-meter diameter. So you can tell roughly what 5 meters is. It's about half the size of this room or so. The largest telescope in the world when I was born, and actually the largest telescope in the world for most of my adult life, but has since been overtaken. We now have telescopes in space. They are not necessarily any larger. The Hubble Space Telescope, for instance, the mirror is about the same size as the mirror in that middle one there, the so-called Hooker 100-inch or 2.5-meter telescope. And of course, more recently, in 2021, on Christmas Day, we launched the James Webb Space Telescope. But there are absolutely huge telescopes coming online fairly shortly in the next few years, because even though space telescopes have their purpose, get above the turbulent effect of the Earth's atmosphere to get away from the blurring effect, but it's still a good idea to build larger telescopes because you can collect more light and see fainter objects. It's a bit tricky to get really big telescopes into orbit, so there will always be this complementarity between smallish telescopes going into orbit and huge telescopes on the ground. So that's what's coming along in a few years' time, the so-called extremely large telescope. And I'm sure you can't see, but there's actually a person standing in front of it there. Okay, this telescope mirror will be approximately 40 meters in diameter, 40, not 14, 40 meters in diameter. Absolutely huge compared to the telescopes in past centuries. So what was our first view of the solar system 400 and something years ago? Well, Galileo looked at, as well as looking at the stars of the Milky Way, he looked at these bright points of light that we know are the wandering stars, the wandering planets. When he looked at Jupiter, he saw our own eyes show us 4 stars which wander around Jupiter, as does the moon around the Earth. He made a note of where these moons were, night by night. He recorded where these extra stars appeared to be, and as Jupiter moved through the sky, these little stars seemed to stay with it and appeared to be, from night to night to night, always moving around Jupiter. So here was evidence that some objects, we don't necessarily know what they are, but some objects appear to be orbiting around Jupiter as the center of their little system. So that means that no, not everything rotates around the Earth. The Earth is not the center of the universe, because at least for these 4 objects, the center of their universe appears to be Jupiter. So this was against dogma at the time, so it is a very important observation to show that there is clear evidence that the Sun might be the center of the solar system, but the Earth certainly is not. He also looked at Saturn to try and work out what it was that was going on there. Telescopes weren't as good 400 years ago as they are today. Now we can build optical equipment which is essentially perfect. In other words, it works within the laws of physics and is not subject to any aberrations, because we can't make the glass surfaces or the mirror surfaces accurate enough. But in Galileo's day, he was rather confused by looking at Saturn and seeing 3 blobs and not quite being sure what he saw. The middle one considerably larger than the 2 lateral ones. And indeed, a number of other people turned their telescopes on Saturn to try and understand what they were looking at, and everybody got a slightly different view, and nobody could quite be sure, are we talking about a planet with ears? Are we talking about something with handles on the side? Are we talking about something like that? It took quite a few decades for people to realize what it was they were actually looking at, simply because of the aberrations in very early telescopes. And Huygens in 1659 eventually said, well, I think what we're looking at is a spherical body with a ring around it. And so at that point, it wasn't universally accepted at the time, but if we compare that with a Hubble Space Telescope image, yes, that is what we were looking at. And so it took a few decades to realize that all of these things are just an image of this thing with poor optics. So kudos to Huygens for working out that, yeah, it's a rather weird thing, but it's a spherical object with a circular ring around it, because it could have been, in principle, so many other shapes that were consistent with the images that were being seen at the time. And Saturn wasn't the only confusing planet at the time. Mars was confusing as well. Schiaparelli, for instance, according to his notebook, I love this notebook because he's got bits of paper stuck in with half of stamps. He didn't even want to afford to waste an entire stamp sticking it down, so he cut the stamps in half and then posted them in. But this is his notebook in which he was seeing what's going on Mars, and he drew in exquisite detail some of the features he was looking at. And he described some of these features as canali, meaning channels. There appear to be some channels in the surface of Mars. But unfortunately, canali got mistranslated as canals. And therefore, people then thought, well, if these things are canals, canals are artificial. If they're artificial, we didn't make them, so somebody else must have made them. So there must be inhabitants on Mars who are digging these canals in order to get water from the poles to the equatorial regions. So Schiaparelli said, I think I can see straight lines, but other people said, I can see canals, and therefore Mars is occupied. Lowell in particular, Percival Lowell, American from the 1890s, picked up on this idea and used his telescope to look at Mars. He came to the conclusion there can be no doubt that living beings inhabit our neighbor world. A lot of people thought they could see straight lines, but he was absolutely adamant that these straight lines were A, real, and B, made by some intelligence other than us. He was quoted as the greatest authority on the subject. I'm not sure who declared him as the greatest authority on the subject. I think he might have said that. But certainly in the early 1900s, this was not necessarily universally accepted, but there was a lot of feeling that maybe these things are real. But actually what was happening is Lowell was using a big telescope like this. A huge amount of light was being gathered by the front element of the telescope and being focused by a rather small eyepiece at one end, which he was then looking into. And if anybody's had their eyes tested by an optician who then shines a bright light in your eyes, what do you see? You see the blood vessels on the back of your eyes. And it's thought that maybe that's what he was looking at. It was a suggestion that somebody else had seen straight lines, and whenever you see the glint of something, you can convince yourself you're seeing the same thing, even though you're seeing artifacts within your own vision. So this is how he spent some of his time at the eyepiece end of a very large telescope like that. And after a while, it was realized that, well, some people say they can see canals, lines, but other people think maybe they can see canals, but not in the same place. How can that be? If they're there, and we should see them there. How can we see canals in different places? So although the work of Schiaparelli indicated that maybe these straight lines exist, it wasn't long before other people said, well, I can sort of see some contrast, but I'm not actually convinced I can see straight lines, just features which look a little bit straight depending on the seeing conditions, depending on how turbulent the atmosphere is. So the idea of Mars filled with straight lines soon changed to the sort of Mars that we understand today, an image taken by the Hubble Space Telescope, that yes, there are definite features, yes, there's definite contrast. The globe does change depending on whether there are dust storms on there, but no, there are no canals on Mars, and presumably never were, and it was unfortunately the result of people's flawed vision. As soon as we had the possibility of photographing Mars, then the idea of these canals, as it were, evaporated. Amateurs can do a certain amount in terms of observing the solar system. There are lots of different amateur telescopes around. And although they're not necessarily cheap, they can cost hundreds of pounds or thousands of pounds, but the optical quality is so much better than the optical quality of telescopes for people like Galileo, then amateurs today can see far more in terms of detail on planets than early astronomers could. Generally speaking, amateur telescopes fall into a number of categories. Some still use lenses, so-called refracting telescopes. Some people prefer to use mirrors to focus the light, reflecting telescopes. And there's a certain breed of telescopes which have a combination of both refractors and reflectors, using a combination of glass and mirrors, so-called catadioptric telescopes. There's always a desire amongst virtually all amateurs to get the largest telescope that they can afford, simply because a large telescope aperture, large lens, large mirror, means collecting more light. If you can collect more light, you can see fainter objects. Fainter objects quite often means more distant objects. But it also, the larger lens or the larger mirror, means you can see more detail. So not only can you see fainter objects, you can see more detail in nearby objects. So there's always a drive to go from small telescopes to large telescopes, depending on how deep your pockets are. And if your pockets are really deep, then you can think about telescopes like that. This is, yes, it's an amateur telescope, but it probably costs more than my house. So if you're prepared to take out a second mortgage, that gives you an idea of the size. It is a huge thing. And yes, it may cost a five-figure sum, but some amateurs are serious about wanting to be able to see the solar system, see the universe, and so spending thousands of pounds on a telescope is something that some amateurs are quite prepared to do. This drive towards going to larger and larger apertures is not simply something that amateurs do, it's the same for professionals as well. This is a map, or sorry, a diagram of the relative sizes, all to scale, of mirrors or lenses of telescopes. Just to give you scale, in the bottom left-hand corner there's part of a tennis court. In the bottom right-hand corner there's part of a basketball court. And you can hardly see it, but there's a human to scale. So the top left-hand corner, that's not Galileo stuff, this is way after Galileo. The top left-hand corner is the turn of the century, the sort of 1900-ish state of the art, where lenses or mirrors would be about a meter or so in diameter. There's the Hale telescope, the 5-meter telescope, the largest one in the world when I was born. And you can see that there are telescopes that are getting bigger and bigger and bigger and bigger. The largest one at the moment, as we speak, the largest telescope in the world is this one, the Gran Telescopio Canarias, with a mirror diameter. It's made of hexagonal segments, but if we just sort of approximate to a circle, its diameter is about 10 meters or so. Space telescopes, generally speaking, a lot smaller. There's space telescopes down in the bottom left. Not because we don't want large telescopes, large mirrors in space, but simply it's too difficult to get them on top of a rocket. It was difficult enough with the James Webb to fold it up and send it up to where it is now, but we have to put up with small mirrors just because of the inconvenience of having to get them off the Earth's surface into space. But you can see that there are absolute monster telescopes coming online. If you look at this scale, here we have the extremely large telescope. Astronomers are terrible at naming things, so we've had very large telescope, and now we've got extremely large telescope, a diameter about 40 meters in diameter. There's also, that's being built by the European consortium. There's also an American one that they are thinking of making on the top of Hawaii. That's going to be 30 meters in diameter. Smaller and not yet ready. So we're ahead of them. Europe is beating America because we've got a larger telescope and it's almost operational. That, as I mentioned before, that might look large. Again, you can't necessarily get the scale except by looking at the ladders in the bottom right-hand corner, so you get an idea of scale. The main mirror of this telescope was 5 meters, but now we're talking about telescopes coming online with a surface area, collecting area for the light, orders of magnitude larger than this. And this was quite a beast in its day when it was built in the middle part of the last century. Where are these big telescopes? Where are the biggest ones being put? Well, the best place to put a telescope if you want the best seeing conditions, in other words, the steadiest atmosphere, so the atmosphere blurring doesn't reduce all of the details of every object you want to look at, The best place to put an observatory is either on a volcanic island or in the Atacama Desert. So Hawaii, for instance, a number of different telescopes are on the Hawaiian Islands at Mauna Kea. Quite a few telescopes are on the islands of La Palma and Tenerife, the Canary Islands just off the coast of Africa. And another exceptional seeing place where the atmosphere is very steady is in the Andes there, the Atacama Desert in Chile. That particular one, just to give you an idea, if we have a look at what that actually looks like, that gives you an idea of what these mountaintop observatories look like. This is one observatory as seen from the neighboring mountain, as it were. And you can see that there might be a lot of atmosphere down there, but most of the atmosphere is below where you are. If you're high enough, there might be some haze down there, there might be some water vapor down there, there might be some clouds down there. But if you're higher than all of that, you're not necessarily sticking up above the atmosphere, but you're above a lot of the atmosphere, and therefore you can get some superb views from these mountaintop observatories. If that's not high enough for you, you can put your telescope in the back of a 747. This is SOFIA, the Stratospheric Observatory for Infrared Astronomy, where they put an infrared telescope in the back of a 747 and then fly it at 10,000 meters, higher than you can possibly get a mountaintop observatory. Again, that gets you above even more of the atmosphere, rather important for infrared because a lot of the atmosphere will absorb infrared light. So if you want to work in the infrared part of the spectrum, you fly as high as you can. This infrared observatory is now being retired, so watch out on eBay for a 747 going cheap because they no longer have a use for this particular beastie. It's not exactly being replaced with the James Webb Space Telescope, but now that's where they're doing most of their infrared astronomy. Because, of course, the Hubble, who's been around since 1990, it was launched, it's been around for ages. 35 years this space telescope has been in Earth orbit, taking wonderful images of the universe and including the solar system as well. And more recently, in Christmas Day 2021, the James Webb Space Telescope, not working in the visible part of the spectrum, but working in the infrared part of the spectrum. It's a bit of a problem. It has to be folded up. It's a huge mirror, 6 or so meters in diameter, so you can see from the size of the people down here just what the scale is, but it had to be folded up like a piece of origami and then put on the top of a rocket, sent out into space about 1 million miles away from Earth, where it unfolded, and ever since, 6 months or so after it was launched, has been operating and taking wonderful images of the universe in the infrared part of the spectrum. If we compare Hubble with James Webb, so there's a visible image of Jupiter as seen from the Hubble Space Telescope. There's an infrared image of Jupiter as seen with the James Webb Space Telescope. Hubble and James Webb side by side, visible and infrared. As it happens, they have very similar resolution. In other words, the amount of detail they can see in any particular object that's out there is very similar. Generally speaking, if you have a much larger telescope, you'll see more detail, but the James Webb is working at different wavelengths of light, and that means that its resolution is comparable. So we can see a similar amount of detail in these two images, but clearly we see different things. In the case of the infrared, we're seeing which particular elements are absorbing the light. What is Jupiter actually made of? Is it made of ammonia? Is it made of methane? Is it made of helium? We can get an idea of the elements involved by looking at which infrared wavelengths are being absorbed. And you notice there seems to be a little tinge of color top and bottom. That is not color fringing, that's not aberration. This simply means that Jupiter has aurora, just like we do, aurora borealis and aurora australis, because of energetic particles interacting with its magnetic field. If we were to have a look at Saturn, Saturn with the Hubble Space Telescope looks like the classic Saturn that we all know and love. If we compare that with the James Webb Space Telescope, it looks like the planet has disappeared, but the rings are really bright. That's because the planet is made, there's a lot of methane in the atmosphere of Saturn. Methane absorbs infrared light, and therefore we don't see much in the infrared. But the rings are made of icy particles which do reflect a lot of infrared light, so the rings look really bright, even though the planet looks rather dull. With Uranus, we can see the ring system around Uranus showing up very brightly. Uranus has been explored by Voyager, but Voyager just spent a few hours flying by and then it was done. With Earth-based telescopes, or telescopes close to the Earth, or only 1 million miles away from the Earth, we can, in a sense, look at the planet as often as we like. We're not restricted to only looking at it for that 1 or 2 hours of the flyby. And hence we're seeing a storm system on Uranus. We didn't notice anything interesting on Uranus from Voyager because it happened to fly by the planet when there were no storm systems on the surface, whereas now we can watch it at our leisure and see what's going on the planet. Similarly for Neptune, rather further away, more difficult to see detail, but Neptune has a ring system, and again, Neptune has some methane in its atmosphere, so it's not as bright as you would expect. But the moon of Neptune, which is normally quite faint, looks really bright in this particular image in the top left here, simply because this moon, Triton, is made of basically nitrogen ice, which is very reflective in the infrared. So we're seeing a lot of reflected light from the moon, and a lot of light is being absorbed by the planet. So instead of the planet being bright and the moon being rather faint, it's the opposite way round because of the nature of how infrared light works. So where are things heading in terms of our understanding of the solar system as based on Earth? Well, there are new telescopes coming along. This particular telescope called the Chamonix telescope, it was originally called LSST, the Large Synoptic Survey Telescope, but it's now been renamed the Chamonix telescope, and it's now undergoing a survey, or at least it's about to start a survey, a 10-year survey of everything that it can see in the night sky, which means it's bound to pick up loads of objects in the solar system that we didn't know were there. It's going to be doing this so-called legacy survey of space and time. We're going to reuse the acronym LSST, and for about 10 years, this camera that you can see here to scale with a person is going to look at the result from collecting light over an 8-meter mirror diameter, and it's going to be scanning the sky night after night after night, and it is going to be discovering, I'm sure, thousands upon thousands upon thousands of new objects in the solar system that we didn't know were out there because of the nature of how it's able to do these surveys. And as I've said before, we've got big telescopes coming online, hopefully not too long, maybe 2028, only another 2 or 3 years or so. This monster telescope with its 40-meter diameter mirror, again, notice the people on the gantry here and the people standing out of front. It's being built in Chile. It's not quite ready, but it will be soon. It will be able to look in detail at anything that's found by the survey instrument that I've just mentioned. If that survey instrument finds anything interesting, then it can be followed up by having a monster like this look in detail, collecting all the light that can be collected by a 40-meter mirror to see what's going on with these interesting objects that are found by the LSST. So again, if you want to know more about what's happening now, what the Hubble is doing, what the James Webb Space Telescope are doing, and what's going to be happening in the very near future, the LSST program, the Legacy Survey of Space and Time, and what's happening with the Extremely Large Telescope, which will be coming online in a couple of years, exciting things are afoot. These websites here will tell you more about them. Thank you all very much.